we'll take up an example for finding the eigenvalues of the matrix. So let us carefully observe with the question. It says find the eigenvalues of the matrix. There's a matrix A equal to 5, 4, 1, 2. It's a 2 cross 2 matrix. And we know that we can find out the eigenvalues using the characteristic equation A minus lambda I equal to 0. And determinant of A minus lambda I equal to 0. Now let's write A matrix. It's 5, 4, 1, 2. I matrix, this is the identity matrix of order 2 cross 2, which is 1, 0, 0, 1. And let's write A minus lambda I. 5, 1, 4, 2. And here it is lambda into 1, 0, 0, 1. And then we solve this. 5, 4, 1, 2 minus lambda gets multiplied with the identity matrix lambda 0, 0 lambda. And then we subtract these. So we subtracted element by element wise. So 5 minus lambda, 4 minus 0, 1 minus 0, 2 minus lambda. So you can see this is the matrix formed. And we'll find out the determinant. Now we need to know the determinant of this matrix. A minus lambda I, it will be the diagonal multiplied 5 minus lambda into 2 minus lambda minus the other diagonal multiplied. So 4 into 1. So 5 minus lambda into 2 minus lambda minus 4. This will be 10 minus, if you solve it, 5 into 2, 10. 5 into minus lambda, 5 minus 5 lambda. Then 2 into lambda, minus 2 lambda, and lambda into lambda, that is lambda square. Minus minus becomes plus, and minus 4. We rearrange it, it becomes lambda square minus 7 lambda plus 6. So this is the determinant of matrix A minus lambda I. And our characteristic equation would be A minus lambda I equal to 0. So lambda square minus 7 lambda plus 6 equal to 0. So this is nothing but the characteristic equation of the matrix A. Now I'll tell you a shortcut to arrive at this. See, one way is you can just ignore these two parts, these parts, and directly write from the equation in minus lambda on the diagonal side. So 5 minus lambda here in the diagonal, 5 minus lambda, 2 minus lambda, and directly you can put this equation and then solve the determinant. Another shortcut is, which is even faster, directly arrive at the lambda square minus lambda plus 6 equal to 0. Directly arrive at this characteristic equation. So the formula is lambda square minus sum of the diagonals. Our diagonals were 5 and 2. So when we are talking about generally diagonal, that means we are talking about the principal diagonal. So 5 and 2 was there. So sum of 5 and 2 is 7. So lambda square minus 7 lambda plus the determinant of A. Determinant of A was 5 into 2, 10 minus 4 into 1, 6. So this will be nothing but lambda square minus 7 lambda plus 6. So the formula is, for the shortcut, is this. Lambda square minus sum of the diagonals into lambda plus determinant of A equal to 0. Now we'll solve the characteristic equation. In case you don't know how to solve the equation, I'll just briefly explain how to solve such a 2-degree linear equation. So observe this sign carefully. This is a plus sign. Whenever there is a plus sign here, we know that this needs to be divided into roots such that its sum becomes this. So whenever our equation is of the form A x square plus bx plus c equal to 0. So we arrive at the symbol plus, and A into c, the product of A into c should form the value b. But how? It should be a plus of 2 roots. So adding of 2 roots. So if we split it into 2 and 3, okay, so it will become 5. But our number is 7. Okay, we are adding it. We cannot subtract it. Okay, this is a plus symbol. So we need to find something which will add and become 7, and when you multiply it will become 6. So 6 into 1, that is another factor of 6. 6 into 1, and this will become 7. 6 plus 1 is 7. So we'll write 7 lambda square minus 6 lambda minus lambda plus 6 equal to 0. So you can split 7 into this form. So why this? Why addition? Addition because there was a symbol plus. This is the hint how to solve this equation. So when we'll solve it, we'll get the roots lambda minus 6 and lambda minus 1 equal to 0, lambda equal to 6 and 1. 6 and 1 are nothing but the eigenvalues of matrix A. Okay. One other property of eigenvalues of matrix, the sum of eigenvalues is sum of trace of matrix. Actually, not sum of trace of directly the trace, because trace is nothing but the sum of the diagonal elements. So trace is nothing but sum of diagonal elements. So 6 plus 1 should be equal to 5 plus 2. That's the property. Trace of the matrix is sum of the diagonal elements, sum of the eigenvalues. So that's how we solve the equation. We in exam this needs to be done in a quicker way. So that's why there's a shortcut method. Directly form the equation, characteristic equation, lambda minus 7 lambda plus 6 using the sum of the diagonals plus determinant 10 minus 4 6 and solving the equation directly and arriving at the eigenvalues.